Welcome to the video Normalization. This is part of a series for the Access for Professionals videos at Olympic College. My name is Pam Bilodeau, and I will walk you through the concepts contained here. If you are unfamiliar with the concepts of tables, I recommend you watch the video entitled Components of a Table as part of this video series prior to watching this video, since topics covered will assume you have familiarity with the basics of tables. Normalization is a process that is applied to the tables in a database. We normalize tables for two reasons: to eliminate or reduce duplication in the data, and to make tables concise and single subject. Let's look at these two reasons in more detail. One purpose for normalizing tables is so that data values do not get stored in more than one table. Avoiding data redundancy or data duplication is one of the main reasons for normalizing tables. Here's an example with two tables that hold some similar data. Table A tracks customer data, and Table B tracks orders that are placed by customers. Notice that there is a phone number field in both tables. The phone number field is not a key field, so it is problematic to have it in two tables. A record for customer CHI 100 appears in both tables because this is a customer who placed an order. Somewhere along the line, the data entry for this customer's phone number was changed, or perhaps it was entered incorrectly to begin with in one of the two places. Only one of the numbers is correct, but which one is it? Duplicate data in databases can not only lead to anomalies like this, it is also inefficient. Why store the number twice? The information about the customer should be stored only in the customer table, and the information about the orders should be stored only in the order table. The customer ID links the two tables together. Listing individual values in one table only, and thereby avoiding duplicate data, is the goal. This is a design consideration, since different designs will force you to add fields in certain tables in order to make the data work together. By using normalization, you can reduce or eliminate the possibility of redundancy in your data. Another purpose for normalizing tables is so that tables will represent a concise subject. A properly formed table will focus on a single subject, and all of the fields in the table will relate directly to that subject. For example, when tracking people in a table, fields such as the person's name, customer ID, and so on all make sense because they help to describe something directly about the person. If you also track purchases made by that person in the same table, you introduce an indirect relationship to the person. Attributes of a person can include those things that describe the person. Purchases made by the person do not directly describe the person. The normalization process helps to identify and deal with indirect relationships that may exist in tables. All fields in the table need to relate directly to the primary key, since this field epitomizes the table's subject. One way to look at this is that all fields directly describe the subject. You will also ensure that each attribute has only one value for the subject. With our example, each person has only one customer ID, only one last name, etc. When you start to see the possibility of more than one value of the attribute for the person, you're looking at a field that should likely not be in the table, but rather in its own table. It is possible, highly likely even, that each customer will place more than one order over time. The order number is problematic in the customer table for that reason, and also because it does not directly describe the customer. The normalization process is broken down into several levels known as normal forms. The first three levels are known as first, second, and third normal forms. The fourth level is called Boyce-Codd normal form, then fifth normal form follows it. You see this depicted as 1NF, 2NF, 3NF, BCNF, and 5NF. Here are some rules and concepts to keep in mind when working with normalization. Each level builds upon the one before, so second normal form includes all of the constructs of first normal form plus those relevant to second. Third normal form includes all of the constructs of second normal form, which includes first normal form, plus those relevant to third, and so on. For most purposes, a designer can achieve good database design by going through just the first three levels only. We normalize to reduce data redundancy and to focus tables to a single subject. For more information on how normalization works, refer to http://databases.about.com/od/specific products/a/normalization.htm. We will cover more with normal forms in the following videos. To continue your learning on database design, I recommend you watch the next video in the series, First Normal Form. Thank you for viewing this video.